Hi, I'm Mary Kirtland. I'm a program manager with the COM+ services team, and I'm going to talk about designing COM+ applications. The first thing I'm going to do is give a little bit of background information about what some of the application services are that we use with COM+ to build Windows DNA applications. And then I'll look at some of the specifics of how you go about the process of designing an app. So the first thing I want to kind of give some background on is what is Windows DNA? It's our three-tier architecture that helps you build distributed applications. It goes from presentation through business logic and onto the data services layer. This gives us a framework for thinking about how to build applications and how Microsoft technologies fit into them. Where COM+ fits in is in the application services that are provided by the system and are used to primarily build the business logic of your app. There's a little bit of overlap with the presentation layer and a little bit of overlap with the data layer, but it's primarily about the business logic. The key things to Windows DNA are that, one, it is a three-tier application architecture. This is the way we think is the best way to go about building scalable distributed applications. The other main aspect of Windows DNA is that you build your applications from components. Components are basically just reusable binary pieces of software that provide services to an application. This gives you a way to build up your application in increments, and it also gives you the ability to modify your application over time. Now at this point we're not specifically talking about COM components or COM+ components, just anything that you can reuse as a unit of distribution. Eventually you'll pick COM and COM+ services for some parts of that application. The main enablers of Windows DNA are tools that can help you build these components, eliminate some of the extraneous or non-specific work, things like providing a framework for building the component infrastructure itself. You also need to have these middleware services that you can depend on, things that give you transactions or security support, or other things that you don't really want to write because they're part of the system that you need to rely on and don't really have anything to do with your application logic. And finally, it's very rare that you'll have an application that can exist without having to talk to anything else. So we want to be able to interoperate with your existing data and your existing applications. And there are technologies in Windows DNA that can do all of that. The main application services that we're concerned with are first COM+. This is the runtime environment for COM components. It provides a way for you to declare services or interest in services that you want, and we provide the infrastructure that makes those services work. One of the key pieces of this is the distributed transaction coordinator. This lets you compose components into larger units of functionality so that you can make sure that resources that need to be updated as a group are updated all at once or not at all, even if there are multiple components that are used to build up that functionality. We also provide administrative tools that make it a little bit easier to go about deploying and packaging up these applications that are built up of many components. COM+ is really the evolution of COM, which has been around for a long time, and MTS, which shipped with NT4 in the option pack. And we combine those into a single programming model that ships with Windows 2000. And much of the information that I'm going to talk about also applies to developing apps for MTS. So if you do have applications that need to also work on NT4 or have clients that do not have access to Windows 2000 capabilities, many of the same principles will apply. Other key services that we use in conjunction with COM+ are Internet Information Server, IIS, in particular with active server pages, where we're using the active server pages to dynamically construct HTML that will go out to Internet clients. The main thing is that the components encapsulate much of the work that you're going to do within these active server pages, and you use script commands to trigger off actions on the components. You use HTML to provide information about how you want the presentation to be displayed to the user in a platform-neutral way. Another application service that's available is the Microsoft Message Queue server. MSMQ provides a way for you to send messages in a standard infrastructure that you can define exactly what the message format looks like. So this is a great way to combine applications that aren't necessarily implemented at the same time or in conjunction with each other. There's a lot of flexibility in MSMQ. You can guarantee that a message will be delivered exactly once. You can make sure that it gets routed through the least expensive mechanism. You can assign priorities to messages. So there's a lot of flexibility in MSMQ that you don't necessarily have with a DCOM message. And they make a good combination for expanding the range of applications that you can build in a distributed environment. So just to kind of set the baseline, with COM we introduced this notion of objects and interfaces. And the key thing in COM is that all access to an object is through its interfaces. We provide a standard kind of object called a class factory, and the class factory is how you go about creating other objects that you want to interact with. Each object exposes a standard interface called IUnknown, and we use this to let you get to other interfaces that the object might expose. The classes that implement particular objects are combined into a binary unit of code that we call a COM component. And that component also includes things like registration code that helps you publish the information about this component to a particular machine. It also provides information about how to package things together, so how to hook into the underlying operating system. In MTS, we added a few new things, and the primary one is this notion of state management and declarative programming. So we have the basic components, and you talk to them in the same way. You have interfaces, clients get interface pointers, and they talk through those interface pointers to an object. You can specify information at the component, the class, the interface, and with COM+, the method level that indicates how you want to apply services to a particular component. So attributes can be things like, I want a transaction, or I want synchronization, or these are the types of people who are allowed to use this component. Based on that information and some information about the client machine, we create a context that the objects are going to operate in. What this context provides is basically a nice safe environment for your object. It provides information about what transaction you're currently part of, what your security context is, and other things that the operating system and the MTS environment needs to know in order to make sure that services are applied to the object correctly. If you then create a subcomponent from, or sub-object from a given object, we do the same thing. We look at the attributes that are on the newly requested object, and we look at the context information for the current object, and we combine those to create a context for the new object. That is the fundamental direction that we're moving forward with in COM+, is to really make this notion of attributes and context a fundamental part of the programming model. Instead of saying that you need to call an API in order to access a service, where you might call an initialization API and then call another API that says, here's how I want to configure a service. You just declare an attribute and you say what you want to happen, and the system will figure out how to make that work. Another aspect of MTS that has been much discussed is state management. We often talk about MTS is promoting stateless objects, and that's really not the way to think about it. The best way to think about it is that you have to think about where your state is going to be. The key idea is that we don't let you maintain per object state across the transaction boundary. The reason for this is to make sure that you don't leak information from one transaction to another. We want to make sure that the information remains correct and consistent. So there are different types of state information that you can think about. One place that you can keep state is, rather than keeping it in each object, is to keep it with the client. And whenever the client needs to provide information to a particular object or particular component, it can pass the information in its call to a particular interface method. You can still keep object in, or you can still keep state in each object as member variables, for example, in a C++ class or in a VB class. But what you can't do is assume that that state will be maintained across the transaction boundary. So as long as the lifetime of your object is less than the lifetime of the transaction, you'll be just fine. If you do need to maintain state across the transaction boundary, but you don't always want to pass it over from the client, or maybe there's information that applies to multiple clients, you can keep that in something called shared transient state. And we provide a service called the Shared Property Manager that can help you do this. Basically, the idea is there's some place on the server machine that you're going to use to collect up this information and keep track of it. And you probably are going to pass a key over from the client that says, here's the state I want. Or the objects can locate a key and say, here's the state I want out of the shared area. You can also keep state information in a persistent store, like a database. This is the way that you get the most scalability and flexibility, is by keeping the information off in a persistent store and reading it in just when you need it. If you can reuse or share the connections to that persistent state, you can get very high scalability rates. The other aspect of the programming model that's important from a component developer's point of view is that by calling methods called setComplete and setAbort, we can indicate that you're done with the per object state that you have in a particular object when your method call returns. And this lets MTS know that they can go ahead and reclaim the object and destroy it and free up any server resources that might be associated with that particular object. So COM Plus is the evolution of COM and MTS. It's how you combine those two things together. The thing that I really want to emphasize is that the basic programming model between COM Plus and MTS is identical. A couple years ago, we started talking about COM Plus as this thing that was really going to change the way that you built components. That's not what we're providing in Windows 2000. We're providing something that is very much an evolutionary path. And the way that you go about writing components is exactly the same as it was for MTS and exactly the same as it was for COM. You write in-process components, you expose interfaces. If you want to use automation, you have to implement iDispatch. You have to implement the registration code. So the same things that you've had to do in the past, you're still going to have to do with COM Plus in Windows 2000. There are some new services that you can use, however, to expand the range and the types of applications that you can build. So the items that are listed on this slide, queued components, loosely coupled events, the in-memory database, transactional shared property manager, object pooling, and dynamic load balancing, are the major features that help expand your range of design choices. And I'll briefly go through each of those and talk about where you might want to use it in just a minute. There are also improvements to the existing MTS services. So for example, if you're used to using transactions and JIT activation in MTS, and there are times when you might not need a transaction and might not want to use JIT, well, that's a possibility now. We've factored the services out so that you can choose which ones you want. If you don't want JIT, you can still get role-based security, for example. The role-based security has been improved to provide more information about the entire chain of callers. And so there are things that are a little bit easier now in COM Plus, even if you're just using the same services that were available in MTS. So the next couple of slides present some example high-level application architectures that you might use in COM Plus. And the first one is really the prototypical simple application with a FAT client, a Win32 native client. That application is going to talk to a business layer, an application server that is running COM Plus on Windows 2000 and has a number of components operating in the COM Plus environment. And the way that these two layers communicate is using DCOM. So this means that the Win32 application is going to say, I want to create this particular type of object. The object will be created, an interface pointer will be passed back, and the presentation application and the business logic will be communicating directly. Those business objects can in turn use other objects In many cases, they will use data objects that encapsulate access to particular data stores. In this particular example, I show SQL Server, and I show the data object communicating with SQL Server using ADO. That's not the only option. There are several options that you can use for data access, and of course there are several different types of stores you might use. ADO is the easiest, most flexible from a programming perspective. It's a very high level and easy to understand model that can be accessed from scripts and from components in just about any language. There are other options, and they offer different degrees of flexibility, and we'll talk about some of those a little bit later. Another type of application that is very common these days is a web application. In the web application, you have IIS, probably with active server pages, as the aspect at the business layer that's directly communicating with the presentation services or the program that the user sees. And in many cases, this presentation layer is written using HTML or perhaps dynamic HTML, DHTML, and you might even have some client-side components that are helping out in the construction of the logic that you might want to run in your presentation layer. Instead of using DCOM to communicate between the web application and IIS, you use HTTP. So you get a typical HTTP response request that is used to communicate between the presentation layer and the active server pages. Active server pages then call business objects to do some of the work. Since active server pages are interpreted today, it's really important that if you have lengthy work that you might want to reuse in multiple environments, you take it out of script code and you encapsulate it within a component. And as before, these business objects can communicate with the data objects, and the data objects will communicate with the presentation or the data tier. Another aspect of applications that you might want to consider is having two independently developed applications that don't really have any explicit dependencies on each other, but sometimes need to collaborate. They need to share information. A common example that's used in this context is order entry and shipping. You know when you place an order that eventually it needs to be shipped, but you don't need to tie up the order entry process waiting for confirmation that the order will in fact be shipped and when it will be shipped and who will do the boxing and everything like that. So what you can do is you can use messaging to pass information from one application to another. You have a front end that talks to some application and does some amount of work, and that application then sends a message to a message queue, and MSMQ is responsible for sending it on to other applications that might want to use it. Each of those applications can communicate with its own data store, and in fact they may communicate with the same data store in some instances. And there will probably also be a front-end application for that business application that's shown at the bottom of the slide. So those are sort of the common high-level application architectures that you would see in applications that use COM+. Queued components is an interesting new feature that we're adding that wraps message queuing behind the normal COM programming model. So instead of having to explicitly write code to send a message to a queue and figure out how to parse that message and get it over to the correct receiving application, you basically just say, here's a component, I want to expose its interface so that it can be queued, that I don't need to have a time dependence on receiving this message and getting a response back. But if I call this method from a queued client that understands how to do that, then eventually I will get the message and I will understand how to process it. I don't care what the message looks like, I just want to get the message and do some work. This is the way that you get asynchronous or time-independent behavior in COM+. So any place where you're trying to figure out how to get a lengthy operation out of the way, or how to reduce the total amount of time that it's taking for a client request to turn around and get a response back to them, try to find places where you can move part of the processing out of line and perhaps send a message over to a queued component, have it do some work, and maybe update a data store with some status information, or send another message back to someone who knows how to deal with the completion of the operation that you're doing out of line. This is a place where you have to make a decision when you're doing design of, do I care about the message format? If you don't care, Queued Components is a great way to go because you don't have to learn about the MSMQ API. You just go ahead and use the familiar COM programming model. If, on the other hand, you do care about the format of the message, perhaps you're talking to an external application that has a message format defined and you have to talk that message format, then you would need to use the MSMQ APIs directly. Another way that you can combine applications together that maybe don't know about each other, don't know very much about each other, is to use loosely coupled events. This is our publish and subscribe event model, and it works very nicely with Queued Components. In the typical model, or the typical implementation of LCE, your application is tied up from the time you fire an event until the time everybody who's interested receives the message and returns a response. If you don't want to wait for all the subscribers to finish processing a particular event, then you use Queued Components to take that processing out of line. You say, I want to fire this event using a message, and then the event system can go ahead and do work, and you don't care exactly when it happens, you just need to make sure that it eventually happens. The other nice thing about the loosely coupled event system, as opposed to something like connection points in ActiveX controls, is that the subscriptions can be persistent and they don't have to be implemented within every component. So there's no logic that's doing the subscription management within your components. It's all done by the system. Now, the one limitation that really is going to impact people who are thinking about using loosely coupled events is that we don't do true multicast. So if you have tens of thousands of subscribers to every event, this probably isn't the mechanism that you want to use. If you just have a handful of subscribers or a fairly limited number, then you can use loosely coupled events to broadcast that information to this small number of subscribers, and we will provide a way that you can do parallel firing, where we spin up separate threads and fire off events to each of the subscribers as quickly as we can. So it's not true multicast, but it does give you a way to get information out to a number of subscribers without waiting for each one to complete its processing in turn. And again, this is a really great way to combine things that don't necessarily need to know about each other when they are developed. One of the key uses I see for this is doing things like monitoring. You instrument your components to fire off explicit events about events of interest. Things like access violations might trigger an event. If you have things that need to be audited, you might want to fire those off. If you see that resources are being constrained, or there's something that's causing the system to perform not quite as well as it ought to, you might want to fire off an event in that case. And then you can have separately developed monitoring applications that watch for particular events and say, hey, this is something that we really need to take care of. We'll set off an alarm or something, we'll page somebody, we'll do something that will cause this condition to be fixed. The application doesn't really care, the component doesn't really care who does that work or when it happens or how it happens. All it wants to do is raise the flag that something has happened that might be of interest to someone. That's what the event model is all about. Another feature that we have in COM+ that is really going to help people do things that they weren't able to do in MTS is the in-memory database. This is essentially a data cache that will help you get your data out of data stores and close to your business objects. It's geared toward read-mostly scenarios where you have something like a table maybe of zip codes and cities and states. That doesn't change very often, so what you would do is query the information out of the data store, get it onto your application server, your middle tier where some business logic is happening, and then access the data out of memory very quickly. Memory is really cheap. This gives you a way to reduce network traffic back to your data store, and for things that are read mostly, why do the query multiple times? Just cache the information into main memory and use it from there. The reason that we say it's optimized for read mostly scenarios is that we don't have a distributed cache coordinator in this version that ships with Windows 2000. So there's a separate cache on every machine that reads a set of data out of the database. And data changes have to go through the IMDb layer. You can't update the database and have it propagate back to however many caches of this particular information there might happen to be. So if you're doing things where the data needs to change, then you have to make sure that a single machine is going to be able to handle that. Or you provide some mechanism that can refresh the cached information no matter how many copies there are. But you would have to implement that refresh mechanism yourself because it's not built into IMDb in the initial version. You can, however, use it as a write-through cache. So if you can work on one machine, you've partitioned your data, you've partitioned your client so that every client and every data change is only going to happen on one machine, then you can run the information through IMDb and then pass it on to the data store excuse me, at a later time. In MTS, we had something called the Shared Property Manager, and this gave you a way to manage that shared transient state that you might need to maintain across transaction boundaries or between components or between clients. In COM+, we introduced this transactional shared property manager that's built on top of IMDb. The main reason for doing this is it uses the familiar shared property manager interfaces to access the functionality of IMDb. So you have a choice of using IMDb directly through something like OADB or ADO and use a kind of a database approach, or you can use the object-based approach of the shared property manager interfaces to get access to your state information. One of the nice things about the shared property manager in COM+ is that it's machine-wide, not per process. So you can share information across several COM+ applications, whereas in MTS, all of the information was specific to a particular process or a particular server package. Again, this is a place where you manage the data that you need to keep across transactions but don't necessarily need to store away in a persistent store. And it's a good thing to use for hotspots in your data, things like web page counters or IDs that you need to generate very frequently, where updating the database every single time that you needed a new number or needed to store some information away would just cause the data store to be hammered and performance would suffer. So this is a way where you cache some information into the main memory, you update things, and then you sort of write it out to the database on a as-needed basis, but not every single time that you are accessing a particular data. In MTS, we provided a feature that looked like we were going to let you pool objects. We would create the object ahead of time and we'd just have them sort of sitting around, and when you needed them, we could grab them really quickly rather than having to go off and create the object and initialize it. Although it looked like we did that, we didn't really ever do it. Every time that you deactivated an object, it was destroyed, and the next time that you created or accessed the object, a new physical object on the server would be created. In COM+, we really do support object pooling, and this will let you build a pool of similar objects per process. You put the objects in the pool, and when you ask for a particular object or you call a method on an object that has been just-in-time deactivated, then we'll first look in the pool, and if there's something there, we'll pull it out of the pool very quickly. There are good things and bad things about this. The good thing is that if you have objects that are very expensive to create, this is a great way to create them in the background and create them ahead of time and then just access them very quickly. It also gives you a way to govern the maximum number of objects that can be created. Otherwise, if there are 10,000 clients that ask for a particular object, we would just go ahead and create the 10,000 objects, whether the system was able to support that or not. We would try. If you had a pool of objects, on the other hand, you could say, this is the maximum number of objects that I can support, maximum number I want created. And if someone tried to request an object and the pool is empty, then they would get an error that said there's no objects available. So this can help you manage the resource usage on your server machine. So that's kind of the good side. The bad side is that objects that are in a pool can't have thread affinity. And 90% of the objects that have ever been created to date do have thread affinity. In fact, every VB component has thread affinity. So if you're using Visual Basic 5, or Visual Basic 6 to build your components, you're not going to be able to build components that support object pooling. We're hoping that in the future this restriction will be eliminated and that you will be able to use any language to build your components that will support pooling. You will be able to use Visual C or Visual J++ to build, in the 6.0 versions, to build objects that can be pooled. The key thing, if you're familiar with threading models, is that you have to support the free-threaded model, the neutral model, or the both model in order to get objects that will support pooling. The other aspect of object pooling that I want to point out to people is that it sounds like a good thing that you just might want to blindly apply. Creating your objects in the background sounds like a really great thing. However, what we found in some of our initial performance tests is that it doesn't necessarily give you any benefit. So you should check out your performance and see if your performance requirements are met without object pooling, and then whether you get any benefit from turning pooling on. And this is something where you might want to build the simple version of your component, particularly if you're a VB programmer that doesn't support pooling. See if it meets your performance requirements. If it doesn't, then you can think about taking the hit and implementing the component using another language, and then enabling pooling and seeing if that will get you the performance benefits that you need. The primary places where we think this is really going to be helpful is when the construction costs are really, really high, or the initialization costs are very high for a particular component, or where you run into issues where you're running out of resources that the components need to create objects. Another issue that we've seen with MTS is that when you wanted to scale up to support high numbers of clients, you needed to add additional machines. So you'd have multiple copies of a particular application or particular package running on separate machines, and that you would balance the load across those machines in a static fashion. You would have particular clients always go to one machine, or you would use DNS round robin to arbitrarily associate a particular request with a particular machine. The problem with that is it's very hard to maintain the configuration, particularly as the number of clients becomes very large. And it's also not sensitive to issues like a particular machine failing. So if the client is always going off to one machine and that machine happens to fail or to be offline for some reason, the client's stuck. There's no way for it to determine that there are other machines that it could go to get its work done. In COM+, we add real dynamic load balancing, where you specify a group of machines that all have the same components installed, and you can go ahead and have the client get to any of those machines based on an algorithm that runs on a particular router machine. The algorithm that we're using in COM+ in Windows 2000 is a response time algorithm. So we collect statistics in the background and we figure out which machine is likely to give you the best performance when you do an object creation. The other thing to watch out for with load balancing is that we only do load balancing today when you first create an object on your co-create instance or your create object call from VB. We do not do a new load balancing request every time a component or an object is activated and deactivated. So every time you make a method call, we're not doing a load balance. This is actually turns out to be a good thing. If you end up doing a load balancing operation on each activation and you're using stateless components, basically what you end up doing is saying that every method call to a particular object needs to have a load balancing request. And what you end up doing is you go to the router machine and you say, I need to access an object, and it goes off and it figures out which machine to use, picks one, and makes the call. That adds a lot of overhead per call. On the other hand, if you just do the load balancing when you create the object, from that point on, the client and a particular machine where the object was created can communicate directly. And so every time there is a particular method call, it just goes to the same machine, instantiates an object on that server machine, does its work, and returns. That tends to give better performance than if we actually did a load balance on every single method call. The main reasons that you do this are first to improve your scalability and also to give you that additional availability situation where a particular server machine is offline. That's okay. We'll just use another machine that happens to be in our load balancing cluster. Most COM+ components that you write are going to be load balanceable. The main thing that you have to watch out for is any implicit machine affinities that you might have. The dependence on a particular path, on a particular server name, state information that you're keeping on a particular machine. You need to make sure that if you get routed to a different machine, you can still operate. That state information might not be available to you. Okay, so at this point, we've looked at a very high level, what the different application services are and the new features of COM+ that you can use to build applications. And so for the remainder of the talk, what I'm going to look at is a process that you can use to think about designing your applications and point out some of the questions you should ask when you are using COM+ to build your app. So this is a very, very high-level look at things that you do when you're designing an application. You have to figure out what your business problem is. That ought to be a given. And once you've done that, you work out what the functional requirements are. In many cases today, we use things like use cases and scenarios to figure out what the application needs to do from the user's perspective. Another part of this that's important, though, is to figure out the business objectives and the non-functional requirements that are associated with your application. Business objectives are often things like we need to be able to improve throughput, or we need to be able to support an expanding number of clients. The number of calls per day is going up. We need our system to be able to handle that. Those can give you performance information and requirements on what you need to do in order to make the business happy with the application that you develop. There can also be constraints like we don't have any money to buy new hardware, so the application has to run on what we've got. And that's going to have a substantial constraint on how you go about designing your application. You might have constraints like our enterprise is totally Windows 2000 on the server side, and our clients all support Windows 98 with IE5. That information provides some constraints on how you do your design. If you had a different constraint of our internet browser that we want to use for all of our business applications is Netscape Navigator, then you would have a different set of constraints on how you go about doing design. So once you've defined those non-functional requirements and the functional requirements, you can start doing some modeling. This is where you start thinking about the logical objects in your system, how they fit together, what you might want to store, what the services are that you're going to use to build the application. And from that point, once you've got an idea of the core concepts and how those work together, you go ahead and refine that until you get to a point where you have defined some components that you can go ahead and implement. So one of the things that I want to point out up front is that many people use object technologies and object-oriented analysis, object-oriented design to do their logical modeling of a problem. And that's perfectly fine, but object-oriented analysis and design are not exactly the same as the way that you want to go about designing components. Typically when you're looking for objects, when you're doing this logical modeling from an object perspective, you're focusing on the concepts, the things in your system. And then as a side effect of that, you figure out what they can do. But what you're really trying to do is build a model in the computer that matches up to the reality of the world that people interact with, using similar terminology so that you get this nice traceability from business requirements, the way that users talk about them, to the core concepts in the system the way that analysts talk about them to actual classes in your implementation. When you look at things from a component design perspective, you're typically looking more at the services. So you're focusing on what things need to be done. And sometimes it's not always easy to figure out exactly what object ought to own those. There's several objects that work together to figure out how to implement a particular service. So when you're doing a pure object-based design, you can get yourself into situations where it's not really clear how those objects might be grouped into components. I guess the main thing that I want to point out is that you shouldn't always try to get the ultimate pure object-based model, because you're going to have to change it when you go to figuring out how to build your COM components. And while you often use object-oriented techniques to implement components, it's not necessary. You can build them with a pure procedural language. You could build them with assembly language if you really wanted to. It would just take a lot longer. So what are some examples of non-functional requirements? Well, the first one that you really need to tie down is performance requirements. Very often we get a performance requirement that says it has to go fast. This isn't a requirement, it's a wish. What we really need to know is what kind of response time do users expect? How many clients are there going to be? How often or how much of the time does the system need to be available? Things with actual numbers associated with them, so that we can test the performance of the system we build against the requirements. And this gives us a way, particularly with components, to build a prototype application, do some testing, figure out where the bottlenecks are, and then selectively tune or optimize the implementation to meet the performance requirements, rather than blindly optimizing everything from the beginning. Typically, you pick the wrong thing to optimize. So the better approach is to get your requirements up front, do some testing, figure out where the real problems are, and then fix those. Other constraints or requirements that you need to look for are deployment constraints. It's very rare that you would have the opportunity to build an application completely from scratch. Usually there'll be an existing database that you need to talk to, maybe multiple databases you need to talk to, and potentially existing applications as well. So those applications are going to be on certain machines. They're going to have certain ways of communicating with those, and you have to fit into that. You're not going to be able to change it in most cases. There are also topology constraints. What type of network do we have? Now, you may not be able to say, well, that network that you've got, the internet connections that you've got aren't good enough. Please change them so that my app will perform acceptably well. You have a particular topology, you have to design around it. Another very important type of non-functional requirement is security. And this is not just access to a particular program, but how do we protect access to data? Are there certain types of data or certain rows of data in a database that everyone can't have access to? So you might have things that say, these particular user accounts and the detailed information about them can only be accessed by the account manager for those accounts. If you're an account manager for some other account, all you can do is get a summary information, the name of the account and who the account manager is, but you can get the detailed information about your own accounts. You might have things that just say, this person is not allowed to modify information, but they're allowed to read it. Another aspect that you need to think about is, does the data need to be protected in a fashion such as encryption? Are there any constraints on passing the information around in the normal human-readable form? For example, if you have a credit card number, you might not want to pass it around as the plain text credit card number. You might need to encrypt it in some fashion. And while there are ways for the system to do that at a very low level, for example, using RPC packet encryption, those things have a very high overhead, and it's very difficult to specify them with a fine granularity in the COM+ programming model. Whereas you could define at the application level that for this interface, this particular method is going to be encrypted, and here's what you have to do to unencrypt it before you can use it. So in some cases, it's much better to do that data protection at the application level and define it as part of the contract between a client and a component than it is to rely on the underlying infrastructure to just blindly protect all the data that's going across the network, for example. You should also think about how the work of the application is divided up into transactions and workflows. Are there particular sequence of things that need to happen in particular orders? What triggers go from one operation to another? Are there things that need to happen as a unit? For example, the typical example for transactions is if I'm making a withdrawal or a transfer excuse me, from my account in my bank, I want to make sure that when I make a payment that the information both comes out of my account and goes into the payee's account. So I don't want information to be taken from my account, or money to be taken from my account, and not to go anywhere. If it doesn't make it to the payer or the payee, then I want to make sure that it doesn't get taken out of my account at all. Those boundaries and restrictions on what information has to happen as blocks are very important to think about, even when you are at a very high level or abstract level of design. And the reason is that you don't have ultimate flexibility to specify some of these constraints on a per method or a per method call level. And so you need to think about what the transaction requirements are of particular methods and how they group together when you're figuring out what methods go in a particular interface, what interfaces go in a particular component, what components get packaged together. So these requirements, even though they aren't directly tied to any particular scenario, end up impacting your design. So there's two typical types of objects that you'll see running within a COM+ environment: business objects and data objects. Business objects encapsulate real-world business operations. So you have very fine-grained objects that might encapsulate a particular business rule. The reason that's important is you want to make sure that these operations are specified one place. You don't want a business rule to be located in multiple places, because when the rule changes, then it's very hard to update the system. You'll also see objects that are control objects. They basically enforce the sequencing of rules, and they make sure that other objects are called to apply specific rules. Very often those objects that control sequencing are the ones that will interact directly with the presentation layer. So some of the things that you have to think about when designing your business objects. The first thing is that you shouldn't try to, in your initial cut at making a business object, be all things to all people that might ever want to use this object. You look at the known clients. Who wants to use this object today? And you provide the functionality that those clients need. Now you might think that, oh, there's something obvious I'm missing. You know, I've got to create new invoice operation, and I've got an update invoice operation, and I've got a query operation. Gee, it might be nice to be able to delete an invoice or to mark it as paid, or something that's obvious from thinking about the context that this object might be used in. And in that case, it's probably worthwhile to flesh out the set of operations that are exposed by the object. But when you start trying to dream up potential clients who might be doing something a little bit different, then you probably want to stop and say, okay, we're going to get one version of the object out there, and then if someone else comes in, we can add a new interface, or we can design a new object that will meet their needs. Another thing that you want to watch for is making your methods very fine-grained. What this means is that you want to make sure that they do one thing, and they do that very well. Methods that do one thing and objects that do a cohesive set of things that are related are much easier to reuse than objects that, or methods that do a lot of things, or objects that do a lot of things. One, you get this weight factor of, well, this is a kitchen sink object, and I don't want to take the hit of loading it into memory in order to use it. And the other is that if you have very complicated operations, those may be ones that just aren't applicable to any other client but the one that's using it. So you're going to get your most reuse if you do try to break things up into separate steps and separate methods. You have to think very carefully about how you're going to pass state information around in your business objects. The one thing that you have to think about is, am I going to be keeping the information on the server, or do I need to pass that in from the client? Do I need to get it from a data store, or does it come from the presentation layer? What that affects is what the interfaces look like to talk to these business objects. How do I get the information into the object in the first place? If the information is kept on the client, then you probably are going to end up with methods that have a lot of parameters that take all the information from the client tier and move it into the business object. And the business object will use that information to complete one method, do its work, and it'll go away. If, on the other hand, the information is kept in a data store, then typically the client would need to present some key information that the business object would then use to retrieve the information from the store or from a transient shared area, bring it into the object, do its work, and then return the result back to the caller. There are very few cases at the high-level business object where you would probably keep a lot of per-object state information. Typically, when you would do this would be for internal business objects that are not directly accessed by the client layer or the presentation layer, that you know are only going to be used within the context of one transaction. An example of when you might use this is when you're creating a master record with several detailed records, and you want to build up this composite thing and then hand it off to a data object to store. A typical example would be an invoice with multiple items on it. So you could have a method that said create the invoice and then add items to it one by one. As long as that was all done within the context of one transaction, that would be a perfectly fine design, and you would keep the state information about that invoice within a particular object. If, on the other hand, you were expecting the client, the end user, to pass information about one object at a time over to the business object, you wouldn't want to keep that information in the per object state, because then you'd have to keep this business object alive on the server, tying up resources until the client decided it was done. And clients have an annoying tendency to wander off and not complete their work before they're finished, and this poor business object is just sitting there waiting to find out when it's done, and it never gets any feedback about that. So then you end up having to design things like timeouts and other things to clean up your resources. It'd be much easier just to say, here's all the information, do some work. And that's typically the approach that you'll see when you're going from the presentation layer to the business layer. You need to think about how these particular object methods or particular services that you want to implement at the business layer work together. What things use the same resources, what things share responsibilities, what things work together to form the work of one transaction. Those are things that will typically compose together into a higher level operation. And so you want to make sure that things that use the same resources are probably going to be located in the same business object. Things that share the same transactional requirements ought to be located in the same requirement, or they ought to have their transactional settings configured in such a way that they can work together to build that higher level behavior. You also need to look at security requirements. This was a little bit worse in MTS than it is in COM+ in Windows 2000, because there were limits on the granularity of how you could set security. You could not set security in MTS on a particular method. You basically had to say, these types of users have access to this component, these types of users can have access to individual interfaces, but you couldn't restrict access to a particular method. You can do that in COM+, so this is a little bit less of an issue, but you still probably want to have methods that have similar security requirements in a particular interface or a particular component. And you also should think about this issue that I mentioned before about, can I pass information around in plain text or do I need to encrypt it? That's going to impact the interface design for these business objects, particularly that talk to the outside world. The other primary form of object is a data object. And what you want your data objects to do is be responsible for the accuracy and correctness and consistency of your data, a particular type of data. And the reason that you do this is to ensure that all the responsibility for that particular piece of data is in one place. If something goes wrong with that data, you know where to go and look for problems. If, on the other hand, you distribute the responsibility for checking your data across multiple objects, you let different business objects check the data and then just assume at your data object layer that, oh, the data that I've got is okay, then you can end up with situations where your data store can be corrupted, or you get inconsistent information in different places in the data store, and that's very hard to go back and correct. So the data objects are the last line of defense. They're responsible for making sure that the data that you're keeping in your company does not get corrupted. Now, they may in turn use system services to ensure that the data is in a consistent state. For example, you might want to use rules within a SQL Server database to make sure that you have referential integrity, or that when you do a delete, certain tables are deleted as well, certain other rows are deleted. But for the most part, you want to make sure that there isn't responsibility for ensuring correctness at some higher level of the program. You don't want that responsibility to be spread out in your business objects. So what are the things about data objects? Well, again, there's this issue of where you're going to put the state. And here's where this whole argument about stateless and stateful objects really kind of gets confusing for a lot of people who are thinking about using MTS or COM+. Typically, when you have a data object, it's only in operation or only in memory during the lifetime of one transaction. Remember, I said before that the rule in MTS and COM+ is you can't share state across transactions, but within a particular transaction, it's perfectly okay. So you might want to have a data object that is stateful, that you can set particular properties of, that you can call individual methods to build up the composite data, and then have a save method or some sort of method that would indicate, okay, now it's time to write that information out to the store. Or you can choose to use the same approach that you would typically use for a business object, where you pass all the information into the data object at one time. It does some processing to ensure that the data is okay, and then just passes it on to the data store. And then the object goes away as soon as your transaction is completed. But the key thing is that you make a choice of whether you want to design your interfaces so that you maintain information from one method call to another within a transaction, or whether all the information needs to be passed to the data object per method. The typical behaviors of data objects, you probably just want to make sure that these are there: create, read, update, and delete. And the thing that you want to watch out for if your objects need to be protected in any way is, do I want the update and the create and delete operations in the same interface or the same component as my read operations? There are cases where the operations that change the database are going to have different transactional requirements than the operations that just do a query. And in MTS and COM+ both, you can only set the transactional level, the type of transaction support you want, at the component level. So if all of these operations are in a particular component, you are going to get the transactional behavior that's specified. So if you do have them combined, you might want to set your transactional settings as supports transaction, and then make sure that your business objects that are only doing queries don't have an enclosing transaction, that they can just go ahead and do a query without the overhead of doing a full transaction. But when you're doing update operations, you do want to make sure that the business object has a transaction created that the data objects will fit into. You might also choose to separate things out so that it's a cleaner separation when you're trying to restrict access. There'll be certain people who are allowed to query, probably more people are allowed to query than are allowed to also do updates. You should, like for business objects, think about what services in your data objects use similar resources. If they talk to a similar database or the same database table, maybe those are good clues that those are things that you want to keep in one data object. You want to make sure that you're able to share connections to a database. Those are very expensive things. They're very limited in number, so it's important that you be able to share access as much as possible. And as I mentioned before, the transactional behavior is really key when you're doing data object design. Transactions are expensive, so if you don't need them, if you're only updating one table and you can rely on the underlying data stores to do the work, or if you're not doing any updates at all, maybe you don't need to have a transaction required by this particular object. On the other hand, if you're updating multiple things, or you can't rely on the containing component that's calling you to do transactions correctly, you might want to make absolutely positively sure by setting your transactional behavior to require a transaction. So even though we make it really easy to say, I want a transaction, and we do the work of getting that all set up for you, you still need to think about where you want transactions and what the boundaries are there. We're not getting rid of the need to think about that part of design. Just making it easier to implement. Again, you have to think about who is allowed to do various operations on your data object, and to split those off into methods that have particular role-based security applied to them. If you really want to make sure, you might want to split off into separate interfaces, different approaches that you can take depending on what platforms you need to support, and what kind of errors your clients are willing to accept. And one of the things that you might want to watch out for with dividing things up into multiple interfaces on a particular component is that script clients can only access the default iDispatch interface for a particular object. So if you have divided up the behavior of your object into multiple interfaces, the script client might not be able to get to all of the services. And that can be a good thing or a bad thing. You make sure that the services everybody can get to, or that you want everyone to have access to, are on that primary interface. With COM+, you are able to selectively set the security settings on particular methods, even for the dispatch interface, so you can cause them to get a security error when they make a call, but you can't hide the fact that that particular method is there. If you really want to hide the fact that the methods even exist, you split them off into a separate interface, or potentially even a separate component. The thing that you want to think about from the perspective of who is using these data objects is, are they going to be used directly from the presentation layer? Are they going to be used by business objects I trust? Are they things where I don't want to have to rely on any behavior of a particular business object? I'm going to make sure that all responsibility for my data is encapsulated within my data object. And you also need to think about the language that those clients are written in. Again, this is mostly to make sure that if you have clients that are using script languages and can only access iDispatch, that all of your functionality is provided through that default automation interface. So just a quick note on some things that you might want to think about for the presentation layer. These are usually ActiveX controls or automation components, depending on whether you've got a physical display or you're just doing some background processing. They usually run in process, so they will typically be running within a browser environment or within the context of a containing Win32 application. And one of the things that you need to watch out for when you're building an application that relies on client-side components is that they may need to be installed over the internet. So that introduces some complications. The first is that when you're installing them to run into a browser environment, they need to be safe for scripting and safe for initialization, or some clients may not even be able to get the objects created in their browser. They've got their security settings set so that they don't enable objects to be created within a particular page. But by marking your objects as safe, then you're increasing the chances that they'll let you do that. The other thing to watch out for with your presentation layer objects is that they're almost always, would probably be a better way to say it, accessed from script clients. And that means, again, that you have to provide your programmatic interfaces through that default iDispatch. If you want to split things off into separate, well-defined interfaces with very tight type definitions, that's fine, but you'll also want to provide some sort of facade that will provide the information that the script clients need through the default iDispatch interface. Now there's a a raging argument within the COM developer community about whether programmatic interfaces should be dual interfaces. A dual interface gives you both a custom aspect and the iDispatch component. If you've just got one programmatic interface, I would say that you might as well make it a dual interface so that late-bound clients can access it through the fastest possible method, the custom part of the interface, and the script clients can access it through iDispatch. If you just do one or the other, then if you only do iDispatch, everybody gets the slow way. If you only do the custom part, then your script clients are out of luck. If you have multiple programmatic interfaces, that's where things become kind of complicated, because even though they're all dual interfaces, only one dispatch interface is ever going to be looked at by your script clients. So that's someplace where you might want to decide, well, I'll have a bunch of custom interfaces, and then my default interface might be a dual interface or a pure iDispatch interface that script clients can use. Another thing that you need to think about is, do I do property-based or method-based interfaces? Property-based interfaces are perfectly fine at the presentation layer because you're working in process. When you're going across the network connection, then you would typically use a method-based approach because you want to try to minimize the number of network round trips that you have happening. So very often you'll see a set of properties and you set the color, the size, particular attributes about an object, and then those are accessed through a script interface based on iDispatch. So a lot of design discussions about component-based design focus on how you design the components, and that's really great. But the other thing that you have to think about is, how do you connect the components? That's equally important with how you design the components in the first place. So I'm going to talk a little bit about how you connect the different physical nodes and logical nodes within your application. And the first one I'm going to look at is data access. The key thing here is that we want to use good principles of encapsulation and abstraction to hide the details of the data layer from your business objects. That's keeping information about where data is stored, the physical structure, the physical schema of the database, hide that away, use the data objects to present a nice, neat, logical model that business objects can work on. There are reasons to do this in a sense that you don't, it's this thing about responsibilities. You don't want to rely on the business objects remembering where the data is, or what the physical data schema is, or what the best ways to access the data are. Get that information encapsulated off where someone who knows the best way to get the data can do it the right way, and put that in a data object. So given your data objects, what are some ways that you can access the information out of the physical layer? Well, there's several different considerations that you need to think about when you're picking a data access technology. We have a lot of them. We have DAO, RDO, ODBC, OLEDB, ADO. Pick a letter and put a DAO on it, and it's probably a data access technology. The things that you can use to decide on and pick a particular technology are things like ease of development. This could be very important if you have a very short development life cycle, or your developers are relatively new to this particular set of technologies. You might want to pick the access technology that has the best tool support, or is easy for a developer using the language that you use to pick up. You want to make it very easy to build these particular types of components. On the other hand, ease of development tends to conflict with high performance. So we make it very easy to write the programs, but they might not be able to meet the most demanding performance requirements. So what you want to look at is, can I get acceptable performance out of this component with the particular data access technology that I would like to use? If you can't, then you might want to look at a slightly higher performing technology. And you have to think also about the long-term impacts of picking these technologies. Are you going to be able to reuse this component in different situations? Are you going to be able to find people who are able to update it if you have problems? There might be other considerations that are important to your company. The key thing is to think about the non-functional requirements and business objectives and how things fit into the overall enterprise structure and development standards you have, and use that to pick the technology you use. So some of the options that we have are whether you use a native data access API or you use something like OLADB or ADO. Those are things where you have greatly different ease of development standards, different tools support standards, and different flexibility. You know, if you use a native API and then you change your underlying data store, then your data object is going to need to be rewritten. But if you're using something like OLADB or ADO, you might just be able to update some configuration information and not really need to change the code very much. You also might look at something like the difference between using dynamic SQL and using stored procedures. Stored procedures are probably going to give you much higher performance, but you have some flexibility in building up, say, query strings with dynamic SQL that you might not be able to get with your stored procedures. In addition, your stored procedures are typically specific to a particular database. So again, if you think the data store might change or you need to support multiple data stores, you might want to keep that information in dynamic SQL statements. And then with COM+, we have this question of, do I go directly to the data store or do I use IMDb as a local cache for data? And that's where you start thinking about, am I mostly reading this information? Do I have one store where I can do updates? Or do I have to really have some type of interactive development? You also need to think about how things communicate with the external users of your system, both people and other programs. And the thing that you have to watch out for here is, how do we communicate with these people? So the protocol that you use to communicate with an external program or an external user is based on the kinds of user interface that you want to present. If you know that you're using a web browser interface to present information to a user, then your communication protocol might be selected as HTTP, just because, you know, HTTP requests to return HTML, because that will naturally go into the browser. But if you are talking directly to a Win32 application, you might decide that you're going to use DCOM to communicate between the program and your components that are running on the business tier. You also need to think about firewall considerations and security issues. DCOM is really good at communicating over TCP, but it depends on having some trusted domain relationship between caller and callee in most situations, and it also doesn't work really well through all firewalls. So in those situations, you might use an HTTP-based approach to get through the firewall and to communicate with a web server, and then have the server-side processing in the web server communicate on with the data objects. You might also have constraints based on the operating system. You might need to talk to an IBM mainframe, and there would only be certain protocols you could use to communicate with that machine. And you need to think about where these things are communicating. Are they located close together? Are they located over a slow link? Is it a dial-up line? Is it a high-speed data connection? Those are all things that you're going to use to define the protocol that you use to communicate between two tiers. Some of the options we have, like I mentioned before, HTTP and DCOM, but you can also look at something called remote data services, which gives you the ability to use either HTTP or DCOM through a COM component, which can give you a nice option for getting access to your business objects and data without having to choose up front either HTTP or DCOM. You should also think about messaging using MSMQ, or potentially using MSMQ in conjunction with MQ series or some other messaging technology through a bridge. And then there are lower level protocols that you could use as well, RPC, sockets, or anything like that. But the thing that you need to think about here is, you know, am I going to be able to build my application in a timely manner if I pick a particular option? Now, I mentioned a while back that one of the things that you do to improve performance is to eliminate some of the out-of-band work or things that are independent operations rather than tying them all together in one big synchronous operation. COM has been synchronous forever. You make a method call, you wait until you get a response. It's also tightly coupled in the sense that you need to know what interface you're calling. client knows who it's calling, it goes over to a particular object, it gets a response back from a particular interface method. That doesn't always work real well. It's not always what your application needs. Some applications don't need a synchronous response. You just want to say, here's some information, go process it at your leisure. Those are situations where you really want to consider using MSMQ or queued components, again, depending on whether you need to specify the message format or not. And you also have applications that can be developed as independent silos, and you just want to kind of provide some information that somebody might be interested in someday. That's a situation where you could consider using events. You might also consider publishing a message format that people could pick up. And you might combine these together in different ways, using queued components with loosely coupled events, for example. Things that you need to think about when you design parts of your application to work independently are, how do you get status information back to the caller? If I have this operation that's gone off and has been working for some period of time, how do I let the caller know that it's done? You could do that by sending another asynchronous message back, or you could put some status information in a data table that they would pull. You also have to figure out how to recover from operations that are partially completed. For example, you order something and you get some information that says, okay, we placed the order for you, and you assume that the stuff that you order is going to be shipped eventually. Well, what happens if you get to a point where the shipping department is not able to fulfill their end of the bargain? They're not able to ship a particular item to you. Then they have to have some recovery mechanism that can say, okay, we don't have this, we're going to delay this for a while. If you don't want to order this particular product anymore, please let us know and we'll cancel your order. So there's some business logic that has to happen in order to recover from that partially completed operation. You also do need to worry about security. Are you going to be able to communicate between these nodes, and how do you have to protect the information that's being passed back and forth between them? So just some last minute things about, once you've kind of figured out the big picture of, here are the components we want, or here are the services we need to provide, how do you actually group them into components that you're going to implement? Well, first you have picked some classes and they're going to implement particular interfaces. You then have to group those into components. These are the physical packages that you're going to install into a COM+ application. In most cases, you're going to see one class per component. In some cases, you will see that if there are classes that always work together, they will be grouped into one component as well. You then need to group those components into applications and particular processes. And the thing that you have to think about here is that in COM+, applications, or what was called packages in MTS, are the units of trust and the units of deployment. So we do security checks when you cross into an application, and everything within a particular application is trusted. And we deploy applications as a block. So if you want to put two different components on two different machines, or you want to have that flexibility, you need to make sure that those are in separate applications. If you need to make sure that there is a security check, then again, you would need to make sure that the call into that component crosses an application boundary. The thing that kind of complicates this is that today, each class can only be part of one application per machine. So we have two types of applications, one that runs in an independent process and one that runs in its caller's process. And that gives you a way to build up something which is confusingly called a library application. So the things that you have to think about are, where do we want to be activated? Things that are activated on a particular machine, for example. What components share resources? If they share resources, they probably ought to be in the same process. We want to make sure that we are taking advantage of the underlying pooling operations that are provided by the system for us. Those are typically per process. You might also want to make sure that if a particular component fails in such a way that it crashes, that you don't bring down the rest of your system. And so that would be a good reason to put a process boundary around a component or a set of components to make sure that they can't cause the rest of the system to fail. And the same thing goes for security isolation. We need to make sure that a security check is made. We'll put that stuff off into a separate application. And then you need to go about assigning applications and processes to particular machines. That's going to depend partially on your deployment constraints. You're also going to have to tune this based on your performance requirements. You may need to implement load balancing to get the scalability you want. So the key thing here is to not make decisions too early. You want to maintain flexibility in how you assign components to applications and processes as long as possible. On the other hand, if you know about a constraint, decide that up front so that you're not having flexibility that will cause your application to break if the administrator who's deploying it or the solution configurer is trying to install this application and they do it in a way that doesn't meet your constraints that you had assumed when you built the application. So you put in the flexibility you think you're going to need, but make sure that you have constrained the places that should not be flexible.